How are you guys? Welcome back to my YouTube channel. We're still under partial derivative. Today we'll be dealing with second order, the second order partial derivative, whereby we take the second partial derivative. Right. So as you see, if you have given z, let's say you take a partial derivative of z with respect to x, you'll find you take this partial derivative first. Then, as you can see, you'll have that partial derivative. You take partial derivative twice. Again, you take the partial derivative of what you have took. This is like second derivative, but second partial derivative. You repeat. You take partial derivative in respect to x, and then you come again. You take partial derivative in respect to what, to x twice. That means you take twice. So this is either some you if you see something like this, yeah, that means it's a second derivative, the second partial derivative, second order. You take partial derivative with respect to what, to x. That means you take it twice. Or this you can beat, or this you can rewrite that. This is the same as that. If you have seen, the same as this, guys, same as that. Right, that means I've started. Firstly, I've taken this partial derivative, then I also repeat what I did. So same applies, guys. You will see what we're talking. Same here, we have taken this thing, the same thing, guys. You've taken partial derivative here with respect to, you can take partial derivative with respect to y. You've taken partial derivative with respect to x, then you take the second, but now with respect to y. You will see when you are dealing with let us take some example. You see this typical how we go about this. All right, so we're given to determine dy over dx first, right? That is a partial derivative, it's a second. Then they say and second order derivative with respect to x again of the following. We find the first order here. We have 1. We know we've given z to be equals to x squared plus y squared. We take the first order here. You said we should determine the first order. So partial derivative of z with respect to what, to x. Y will be a constant, so we differentiate x, you drop the exponents, will be 3, you subtract 1, you apply the power rule, will be 2. This is the same as what is plus 0. This is simply 3x squared. So you have took that. So repeat. Now you're taking the second, you continue. Now you take the second derivative. You are continuing where you left. You are taking the second derivative. Now second derivative, will you continue, you taking the second derivative. As you see, guys, now you're supposed to take the second derivative. The second derivative now of this, you continue here, guys. That is the second. It's like this thing is like a second derivative, but now second derivative of what, of the partial derivative. You drop the exponents again. This will be 3 multiplied by 2 will be 6, then will be x. This is our what, second order. You start by finding the first order, first derivative of the partial derivative. You come get the second order. So just like that. Depends, they can say third order, but now we have two. We don't have that order, but let's say you have that order, you're supposed to take it again, but now we will see what we are talking about. So that is what we have, guys. So we have now number 2 have given z is equals to 4x plus 5y raised to the power of what, of 3. So sorry guys about this. Little full, a bit little full. So we're supposed to take the first derivative here, partial derivative first order of x respective to what, to x. You apply the power rule, you drop the exponents, will be 3, or you know what you're supposed to do here, guys, right? Then you draw your minus 1, there will be 2. You use the chain rule. Right now you multiply by the derivative of the inside, but check now with respect to x, so will be what, the derivative of 4x will be multiplied by 4. This will simply equals to what, plus 0. This is x, this is y. So yeah, so this partial derivative with respect to x simply is equal to what, 3 multiplied by that will be 12. 3 multiplied by 4 we'll have here 12 here into 4x plus 5y raised to the power of 2. So this is what we have. Now let us find the second derivative. We continue, we get the second derivative. Now get the second derivative. If you find the second derivative, you continue here, you drop the exponents again, you apply the power rule, will be 12 multiplied by 2 is 24, right? We'll have your 24, we'll have 4x plus 5y, you drop the x, you minus 1 there, we'll simply have 1, so you cannot write 1, you'll have 1 there as exponents. So you multiply, use the chain rule, multiply by the derivative of the inside, will be times what there, 4x4 only, but that is simply just what, 0, because here it's y, here it's respect to what, to x. So this will be 24, then multiply by 4 will be 96, 4x plus 5y. This is what we have, the second derivative. So you see, this is how it goes, guys. Now we have number 4 there, given what is there. So 4 there, as you can see, sorry about that. Number 4 there, we've given that z equals to y. We've given z to be equals to y over x. So we know this is the same, as you rewrite this is the same as what, as 1 over x, right, multiplied by y. We know that. We know this, guys, isn't it? We know this, guys. So 1 over this is the same as what, that is the same as minus 1. So z, sexual z is the same as x minus 1 multiplied by y. All right, sorry about that notification. We have this, guys, now. So since we have this, let us try and take our partial derivative there, partial derivative of z, the first order, with respective to what, to x. We'll drop the exponents, will be minus x, there will be minus 2 there. This is simply just y, is simply just a constant. We'll have that. Then we take the second one. Now we'll have we drop gain will be positive. Now 2, negative 2 multiplied by negative, we minus 1, there will be negative 3 multiplied by y. So this is our second partial derivative. So this is how it goes about. So this is how it goes there. Oh, that was number 4, by the way. Okay, we have number 3 here. We have number 3 there. We have number 3 there. number 3 there. So we should have that 4x raised to the power 4 plus 3x squared y plus 2x y squared plus y raised to the power of 3. So we're supposed to take partial derivative, the first order of x. You drop the exponents, will be 4 multiplied by 4, which is 16. Then you subtract the exponents, there will be 3. Come again, you drop the exponents, there will be 6. 3 multiplied by 2, you subtract the exponents, there we'll have what? X. Y simply just a constant. Come here, we have plus, we have 2 here, our constant. This x will be what? 1. We're focusing on x, will be what? 1. The derivative of x is 1 multiplied by y squared is simply just a constant. Y only like this will simply just a constant is 0. There we have 16x raised to the power of 3 plus 6xy, then that plus 2y squared. So let's find now our second. Let's try and calculate our second derivative like this. Second, still here, we're continuing this with 16 now. Say 16 multiplied by 3 will be 48 now. You subtract 1 again, will be x raised to the power of 2. You come now, remember, focus here, x just alone there will simply equals to 1. Will be 6 here, that is 1. We have y is the same as a constant. Taking here, this will be just a constant, plus 0. Then this will be 48 x squared plus 6y. All right, that is how it goes. So this is how it goes about. So yeah guys, yeah. So number 5, we've given z to be ln x squared plus y squared. So let me try and grab this. Okay, I will write it here on the bottom path. All right, we have this here on our bottom path, so I can write this. Right, this is what we have. Let's find the first partial derivative with respect to x. We know how to differentiate ln. Remember, if you find the derivative of ln, the revision, the derivative of ln, let's say you have ln of f of x like this. This will be f of x prime divided by f of x. You differentiate what is inside there on the numerator, then you take the original. So you use that here. This is the same as our f of x. There you differentiate, this will be what? But now in respect to what? To x, there will have 2x. You drop the exponents. This is what? It's y. This will be same plus what? 0. Divide. That is something like constant. Divide by that original x squared plus y squared. So this will be 2x over x squared plus y squared. So we are continuing again now. Be careful, this is a second part now. Second, sorry, not y. All right, not y. We are continuing with our partial derivative. Now we are taking the second derivative now. So this, guys, check on our numerator we have x, also you have x, so please make sure that you use your partial derivatives. Recap partial derivative quotient rule, sorry, not partial. What I'm saying, I'm not partial, sorry guys, I want to say use your quotient rule. What does the quotient rule says that we'll have g of x, right, remember, multiply by the f of x prime minus f of x multiplied by g of x prime divided by g of x squared. We square this, isn't it? This is that is it, guys. So what is in the top here, I will leave in the top will be same as, I will take it as f of prime. What is on our numerator, I'll take it as g of x, f of x, this will take as g of x. So let's write this as it is. Our g of x is same as x squared plus y squared. Then we take the derivative of that. Remember now, fx, this is the same as f of, we take the derivative of this. We follow the formula there, that is a derivative of 2x will be what, multiplied by what, by 2. We have a minus there. Then you write this as it is, 2x. Then you take the derivative of what we have here. You take the derivative of what we have. Remember, in respective to x, make sure there. Remember, in respective to x, this will be multiplied by what? You will be 2. Drop the exponent, you minus 1 there. This is the same, will be like 0 plus 0. Y, there we don't focus on y. So this will be 2x squared plus y squared, or isn't it? Then this, when you multiply, will be minus 4x squared. So this is what we have, guys. This is what we have for now. So those are the typical questions, or we're done with this typical question. That's how it goes. That is how it goes, guys. So here again we have some typical questions. We have some typical questions here. It says determine, okay, you see that it's a first partial derivative, the first order of y in respective to y, and the second partial derivative, the second order with respective to what, to y also. So by the way, we have number 1 there. As you can see, it says z must be equal to x raised to the power of 3y plus x y raised to the power of 3, like this. So our partial derivative here, take note, with respective to what, to y, x will be same as a constant. We leave that x, guys, raised to the power of 3, we do nothing. Y will same as 1 plus x is same as just a constant. Here we drop the exponent, you multiply by 3, you subtract 1, there will be 2. Then this will simply equal to x cubed plus multiply that will same as 3 y squared x, like this. This is what we have, by the way. So you continue, you take the second order. If you take the second order, you take the second order now, like that, of in respect, this will be simply what, it's a constant, will be simply 0. Take the, will be what, 6 y x, like this. So this is simply 6 y x. All right, so hopefully you get the point there. So this is what we have, guys. These are our partial derivatives. This is how we go about finding our partial derivatives. So number 2, where there we have sine, we have z is equal to sine 4x multiplied by cos 3y, isn't it? So we take the first order with respect to y, then this, guys, it has no y, guys. This check, it has no what, simply just a constant. You see, you write that sine 4x. So here we have our y down onto our cos. This will be the derivative of this is what we might use the chain rule. We'll multiply by the derivative of what will be what 3 there. The derivative of cos is what is simply derivative of this is simply negative sine. It will be negative sine 3y. We've used the chain rule. This will be 3 sine, actually is negative, let's just say negative because we have the negative. Let me just include the negative. Will be negative 3 sine 4x multiplied by sine 3y. All right, so we continue then. We're finding our second we find our second now partial derivative there. We continue here, guys, find our second. So still here, this is simply just the same as a constant. You have minus 3 sine 4x, but this guy here, please do not use a product rule here. This is just like a constant. There is no x there, so this will be cos, right? We have derivative of that will be cos 3 y, then we multiply by the inside using a chain rule will be 3. Then this, when you multiply 3 multiply by minus 3 this will be, there we have negative 3 multiplied by that negative 3 will be minus 9, isn't it? So here we have sine 4x multiplied by cos 3y. So this is what we have there. All right. So number 3, let me write it here, then I will grab it down, or I will copy it there on the bottom part. This is what we have this typical question. So we want to attack this typical question. Let's just attack this typical question. So we have this now. I'll take our partial derivative of z, the first order in respective to what, to y. Check, we have y on our numerator and on our denominator, so we'll apply our quotient rule. This is a fraction. We'll apply our quotient rule, guys. We'll apply our quotient rule that states there. This is simply equals to g of x, isn't it? We'll have g of x multiplied by f of x prime. You differentiate that, you subtract, you'll have f of x again here multiplied by the derivative of what, of g of prime there. Then you divide this by g, like that, you square this. So we'll use that there. The top one will be same as that. The bottom one I will choose to be g of x. So g of x, we will write the g of x here. We follow that formula. We don't differentiate. It will be x minus 3y like this. Then the second one, we differentiate f of x, which is the top part. Remember, in respective to y, is simply just like a constant. This will be 0 plus that will be just 2 when differentiate that. Then say minus f of x, we write it as it is, this one. Again, we don't differentiate this part. Then we differentiate f of g, whereby is this the bottom part. There, if we multiply by that, x will simply will be 0. Then differentiate y will be minus 3 like this. Then we divide this all over x minus 3y, we square this. So what we'll have, this is like 0, is like 0, multiply this is simply 2. X minus 3y, same as like plus, there is a negative, multiply 3x plus 2y. All right, divide this by, okay, x minus 3y squared. All right, this is what we have in this typical. So you're supposed to, yeah, now you continue again. Continue. Let's find now the second derivative, the second partial derivative respect to y again. All right, so we have this x, we do again our quotient rule. We'll write this as it is, x minus 3y squared as it is. I don't differentiate that, then I multiply by the derivative of the top, all of the top. Now remember, supposed to find the derivative of the what is in the top. So there I have, okay, no problem. Let me just distribute, but it's one and the same thing. If I distribute these two here, yeah, it's one and the same thing. I have the 2 outside. Let me just in respect to what, to y, this will be what, 0. There will be, we have minus 3, right? Remember we did, you come again there. That is plus, there, this will be 3, x is simply will be equals to 0, that will be plus 2 like this. Remember, we've just differentiating that all of these minus, now minus simply the f of x, simply minus all of the, simply minus all of what, all of let's check, let me not make some stupid mistake. Okay, I've differentiated what is in the top, simply now minus the same thing here, f of this, we are not differentiating that. So let me just make some space. Also here you should be very careful, it's so simple, it's very easy for you to make a mistake here. It's very it's so easy. So minus the same f of that, minus that, now minus 2x minus 3y like that, plus 3x plus 2y like this. Take the derivative of this now of the bottom. Derivative of the bottom, you'll multiply by what, by 2. I will need this space. Yeah, ne, see, cookie crumbles. Yeah, see what's going on. Yeah, all right. So multiply by that to dropping the exponents. Remember now we're differentiating that. Then we'll have 3 minus 3y. Subtract 1. Then multiply by the chain rule. Remember, in respective to y, this will simply equals to what? 0. Multiply will be simply, let me not show even that 0 will be multiplied by, what is this, minus 3, like that. All right, this is our quotient rule all over this. All over again. Remember, we're repeating the all over. Okay, I did this quotient or rule all over what again? The bottom part, whereby is x minus 3y. We see if we square this will be raised to the power of 4. So guys, so this is what it is, guys. I see is so messed up, but this is what it is, guys. There we have this. This is what it is, guys. Here we'll have 2x minus 3y. There 2 multiplied by, okay, 3. We have 3, sorry, there 2 multiplied by minus 3 be minus 6x minus 3y squared. Come to this plus multiply by that 6, multiply here, let me check there, we have 2 plus that, here we have, okay, we're supposed to multiply all of this, because here we have minus 2 multiplied by this, multiply by that, 2, so will be 2 multiplied by 2 multiplied by minus 3, so this will simply equals to positive 12. All right, then we multiply what is left here. We'll multiply x, these brackets are the same, this one and that one, can write it 3y, then say squared into x plus 2y, like this, all over. Yeah, this is what it is. This is what it is, all over x minus 3y raised to the power 4. So here we go. So guys, make sure you don't do any mistake here. Oh, it is so easy to make some silly mistakes. So guys, yeah, this is what it is. So thank you for watching. See you in the next coming session, and please may you kindly subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. And then if it is your first time watching my video, please click that thumbs, feel free to comment and feel free to like. All the best.